for sum and average if you want. Okay. So our general form of aggregates are, we have a list of attributes that we would like to group with, that is G1 through Gn. And we have a list of operations or aggregate operations that we can actually perform. So F1 through all the way to Fm, all of those operations are being performed on individual attributes for your table E. So first your grouping is performed, and then essentially your aggregate operations are executed on those individual groups. If no attributes are given in your left hand side, that just means it's just one big group. That is just one entire table that you perform your aggregate operations on. Okay. Let's see. So all tuples in a group have some values for your attributes that you're grouping by G, and that also means that your all tuple values together that are being used to group them by ends up being your super key, right? They end up defining the list of variables or the list of attributes that can be used to uniquely identify your tuple. Okay. When we are working with these operations or these aggregate operations, remember that all of these attributes are unnamed. We can always name them, as we saw in our project operations or generalized project operations. We can say FJI as attribute name, and that actually renames it to an attr name or some name that of your choice. But in general, all of those computed attributes are unnamed, right? Okay. Okay, so now let's look at one more aggregation example, right? So when we say that how many people have completed each puzzle, we grouped by puzzle name. So remember, this is different from what we did earlier, right? Earlier, we were counting how many puzzles has a person completed. So that is why we were grouping by person name. Here we want to know how many people have completed one puzzle. So Altecruise has been completed by Alex, Carl, and that's it. So Altecruise has been completed by 2 people, right? So essentially that is the question we are asking. So if we want to get that, we would, instead of grouping by person name, we would group by puzzle name. Grouping by puzzle name would get us for each Altecruise, we would have Alex, Carl. For Soma Cube, we would have Alex, Bob, and Carl. And for Puzzle Box, we would have Bob, Carl, and Alex, right? So it is grouping by puzzle name. And then we're counting person name in that list. That would give us the number of people that have completed each puzzle. What would happen if, let's say that nobody has actually done one particular puzzle? So on that note, let's say that Alex Altecruise and Carl Altecruise, let me remove these 2 tuples from my table, right? Let's say that these do not exist in my table. So what would be the resultant table if I perform this operation? Would there be an entry for Altecruise? Because Altecruise does not exist in completed at all, we have no idea what Altecruise is, because puzzle list is not part of our operation, right? We don't know that Altecruise is something that we need to care about. So Altecruise will not exist in our relation, right? So if nobody has tried a particular puzzle, that particular result or that particular puzzle will not appear in your relation, right? Okay. Now let's look at a similar example right now. Let's say that we have this new puzzle called Clutchbox. Clutchbox has not been completed by any of the people. It is a brand new puzzle. And if we do run this particular operation, we would like to see that Altecruise is done by 2, Puzzle Box is being done by 3, Soma Cube is being done by 3 or something like that, and Clutchbox is completed by 0 people. We would like to have that result, right? So can someone tell me what can we do? to get clutch box 0 in my results as well. Well, one thing that we need to understand is clutch box is not part of my completed database, right? So we need an entry that says person name nothing, but clutch box is there, right? So basically an entry for clutch box so that I can then group by puzzle name, and then clutch box would have nothing in terms of person names that have completed it, right? But we do need an entry for clutch box. So if we perform a natural join between puzzle list and completed, it says that natural join won't produce any rows with clutch box. Is it correct? If I perform a natural join, remember it correlates the two attribute names that are common, and then essentially picks all of those tuples that have a common value across them. So borrower.loan ID, loan.loan ID, if both of those two values are same, it prints it out. However, if for a particular borrower.loan ID, there is no entry in our loan table, maybe somebody mistakenly deleted a loan.loan ID value, right? Mistakenly deleted one loan tuple, but we have a borrower loan ID value or tuple, but no loan ID tuple. That particular borrower.loan ID will not be repeated in your solution after natural join, because there is no corresponding value for that in the second table, right? Similarly, if we perform a natural join here, clutch box does not exist in my completed table. So even if we do perform a natural join, clutch box will not come up in my table, right, after the natural join. So puzzle list, bow tie completed, still will not have a clutch box. Can I repeat page 17? Okay, so before I go, let me just go back to page 17 for a second. Yes, so page 17 just says that given that we have this set of group by values or G values that we are grouping by, and we have this set of attributes that we are computing using some aggregate operation, the resultant tuples would have this form where we have G1 through Jn, that is your set of tuples that we group by, and A1 through Am, that are the set of tuples that we are basically computing. Sorry, set of attributes that we are basically computing. And it basically also says that all of those computed values are unnamed unless we actually name them as a particular attribute. Make sense how? Any other questions? Who's totally lost right now? Okay. So if you are lost, you need to raise your voice or just type out a question. So yes, why are you lost? What's going on? Are you lost about this particular thing, or are you lost about what? How about the next page? This one?
I think I'm lost at the operations and the aggregate function has not registered to my head yet. So
Mm-hmm. So okay, remember select and project, right? Those were your general operations. So select would be used to basically select out a particular row from a table, right? Project, on the other hand, actually allows us to get a particular column from a table, right? So those were your select and project operations. Remember that they worked on the table, but none of these were able to compare one value with another value in the same table. We can say that get me the row that has taken less than 50 seconds time, right? In that scenario, Alex Somaku 45 would be selected, right? However, we cannot say that get me the row number that has the maximum time. So get me the user's name that has taken the maximum time in solving a particular puzzle. In that scenario, Alex Altitude 350 should be selected, but that also means that you need to evaluate all of the values in that seconds column to figure out which is the maximum. right? So aggregate operations essentially walk through the values of a particular column and get you either the count, max, min, sum, things like that. Imagine having an Excel sheet that has a column and you can just sum up the values of a particular column, right? So that is usually called aggregate operation. That's something that you're performing across tuples, right? So essentially, we also have distinct for that. And so for this particular scenario, we said that how many people have completed each puzzle. So we are taking your completed table and
Mhm.
essentially we are grouping by puzzle name because we want to have for a particular puzzle name the list of users that have completed it, right? So group by puzzle name and then perform the aggregate operation that counts the list of people that have completed a puzzle. But remember that this count is now over these groups. So each group is handled separately, not just counting all of them. Each group by puzzle name is now being counted separately. And we end up with the list of, with the number of people that have completed each puzzle. So how, and Angelina, does that make sense?
So for the count person name, does that return like a number or
Yes, it
the
will.
person?
Yes, it returns basically a puzzle name because remember that we are grouping by puzzle name. So that attribute is there and a list of counts of that puzzle name. So
Oh,
it would return Altecrews 2, Soma Cube 3, Puzzle Box 3.
oh, okay, okay.
Right? Okay. Okay. So you're welcome. Coming back. So we had that same example, Altecrews 2, Soma Cube 3, Puzzle Box 3. But now we just happen to have this new puzzle that is Clutch Box, where we would like the result to be, yes, LTQs 2, Soma Cube 3, Puzzle Box 3, but Clutch Box 0, right? So for that, we would have required an entry for Clutch Box to be solved by at least one person to be in the completed list. We just can't have null Clutch Box. We can, but we would hope we should not want something like that, right? So essentially what we want is blah, 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 I'll take to Soma Cube Puzzle Box, but also Clutch Box 0. So how can we do that? So one way to do it would be to join these two tables together to make sure that all puzzle names are at least in this table, right? So
Uh-huh.
yes,
So you will put a person name called nothing and you will put inside the completed
yes,
relation.
I would want something like that to help me out, but I will not be explicitly adding a tuple that does that in my
Oh,
completed table, right? Because I would like to do it with some join operation. Right. We remember for Cartesian product, we had all possible combinations that were combined with all other operations. So that allowed us to have all of those tuple values inside another table, right? So combined with another table. Similar to that, we also had natural join that actually, so if we had performed a Cartesian product on these two relations, we would have I'll take